Hello everyone, welcome to Robert Morris University Math 0900. This is Brianne Pernick and we are getting ready to start Chapter 7, Lesson 2. In this lesson we are going to learn how to graph a linear equation by plotting three ordered pairs. We're going to graph a straight line by plotting its intercepts, and we're also going to learn how to graph horizontal and vertical lines. There's only two new terms that we need to know for this lesson, and they are x-intercept and y-intercept. The first topic that we're going to start with is graphing a linear equation by plotting at least three ordered pairs. We have seen that a solution to a linear equation in two variables is an ordered pair. We covered that in the last section, section 7.1. The graph of an ordered pair is a point. We also did that in section 7.1. Thus, we can graph an equation by graphing the points corresponding to its ordered pair solutions. A linear equation in two variables has an infinite number of ordered pair solutions. We can see that this is true by plugging in x values into an equation and obtaining y values. So what I've done for us here is I've created a chart. And my suggestion for you is every time that you have to do this type of problem where you're being given a certain x value and being asked to find the y values, my suggestion is that you always set up a real simple chart like this. What we do is when we're given the x values, which is this column right here, we're going to plug that x value into the x in the given equation, which is this column right here. So we're going to take y equals negative 0 plus 3. We simplify that down. Obviously, this should equal 3. So the y value is 3, and the ordered pair is 0, 3. That comes from the x value and the y value. We're going to repeat this process for each one of the x values that we were given. So we're going to plug in 1. Y equals negative 1 plus 3. So that would equal 2. So that means my y value is 2. The ordered pair is 1, 2. Now we're going to plug in 2, so we'll have y equals negative 2 plus 3. So y equals 1. Ordered pair is 2, 1. Lastly, we have y equals negative 3 plus 3. So y is 0. So we have ordered pair 3, 0. So we have now filled in our chart by showing our work. We obtained our y values, and we also found our ordered pairs. It turns out that all of the points corresponding to the ordered pair solutions lie on a line, and the line extends forever in both directions. A similar statement can be made about any linear equation in two variables. And that brings us to this little bubble right there. The graph of any linear equation in two variables is a straight line. Now, from geometry, we should remember that all we need in order to make a straight line is 2 points. So technically we could get away with picking two x values, plugging it in, finding the y values, and graphing two ordered pairs. The problem with this is that we won't know if our ordered pairs are correct or not. If we do 3 or more points, we can verify that we have drawn our line correctly because if you have 3 or more points that all line up in a straight line, you know that you have done your work correctly. Whereas if you do those 4 points and let's say one of them ends up there, then you know something's wrong, okay? And if you only chose 2 points, let me just draw in 2 points right there, you would never have known that something was off like you knew here. We can see that those 3 points align and that one was wrong. We would never have seen that if we only picked 2 points. So I always recommend doing at least 3 points. I myself always try to do 4. I feel more comfortable with that. So our little directions here are in this little bubble with the steps 1, 2, 3. To graph a linear equation, we're going to find 3 ordered pairs that are solutions to the equation, plot the points, and then we draw a line through the points. So example 1, I have already set up a nice little chart for us. So please remember that sometimes that chart won't be there for you. It's really easy to just draw it. I mean, it's just a series of columns and rows that you can roughly sketch. There's nothing special about it. It's just a really organized way for you to set that up. So I just recommend it. So we're going to find 3 ordered pairs that satisfy the solution. I put in 4. You don't have to do all 4. I just picked 0, 1, 2, and 3 and plugged them into my chart. You can choose to do 3 or 4. It makes no difference. That satisfy the equation y equals negative 2x plus 4, and then we're going to graph the line. So remember, all we're going to do is plug in the x values for x and solve for y. So we have y equals negative 2 times 0 plus 4. So y equals 4. The y value is 4. The ordered pair is 0, 4. Now we're going to plug in 1. So we should have negative 2 times 1 plus 4. Negative 2 plus 4 equals 2. And the ordered pair is 1, 2. Next, we're going to plug in the 2. We have negative 2 times 2 plus 4. We should have negative 4 plus 4, which makes 0. So our ordered pair is 2, 0. Lastly, we have negative 2 times 3 plus 4, which gives us negative 6 plus 4, which results in negative 2. So we have ordered pair 3, negative 2. And now that we have figured out our ordered pairs, we are ready to go ahead and graph them on our coordinate system here. So the first one that we have is ordered pair 0, 4. We have ordered pair 1, 2. We have ordered pair 2, 0. So far so good. They're all lining up. And we have ordered pair 3, negative 2. Our points should all line up in a straight line. If they don't form that straight line, then we've done something wrong. Once we get everything graphed, you just simply want to draw a line through it with arrowheads on each end of your line to show that it goes on infinitely in both directions. So what I would like for you to do now is go ahead and try student practice 1. Go ahead and fill in your chart and graph your equation. Pause the recording and please press play as soon as you're ready to proceed. Okay, at this point you should be ready to check your work with me. So remember, we're plugging in the x value for the x. So we have negative 3 times 0 minus 1, which gives us a negative 1. So our ordered pair is 0, negative 1. We have negative 3 times negative 1 minus 1, which gives us 3 minus 1, which is 2. Ordered pair 1, 2. Negative 3 times 2 minus 1. I'm going to back up one moment. This is not right. That is a positive 1 that we plugged in. So 3 times positive 1 is negative 3. That gives us a negative 4. Ordered pair negative 4. My apologies. Okay, 3 times 2, negative 3 times 2 is negative 6, minus 1 is negative 7. So we have ordered pair 2, negative 7. Then we have negative 3 times 3 minus 1 is negative 9 minus 1, which is negative 10. So we have ordered pair 3, negative 10. And then we want to graph our ordered pairs. So we have 0, negative 1. We have 1, negative 4. We have 2, negative 7. And we have 3, negative 10. Once you verify that your points are all in a straight line, you're going to go ahead and graph them and put the arrowheads on each side. Example 2 requires us to simplify our equation before we can begin with our chart. As you can see here, there is some combining of like terms that we can take care of. So I recommend here, I'm going to rewrite my equation, that before we do anything, we move our 2, this 2, to the other side using subtraction. So we have 5x minus 4y equals 0. That's going to change our chart by making that equal a 0 on the other side. It just is a little bit more simplified as we're solving for y. We're still plugging in our x, but there's just a little bit less work to do each time. So we have 5 times 0 minus 4y equals 0. Negative 4y equals 0. Divide both sides by negative 4, and y is going to equal 0. So our ordered pair is 0, 0. Now we have 5 times 1 minus 4y equals 0. That makes 5. We're going to have to subtract that 5 from both sides. So 4y equals negative 5. Divide both sides by negative 4. A negative divided by a negative makes a positive 5/4, which is 1 and 1/4. So we have 1 and 1 and 1/4. Next, we are plugging in 2. So we have 5 times 2 minus 4y equals 0. That is like a 10. We're subtracting 10 from both sides. I'm skipping just a couple of steps to save some room in my box here. So I have negative 10. Divide both sides by negative 4. We have negative over a negative makes a positive. 10 over 4 will reduce by 2 to become 5/2, which is 2 and a half. So the ordered pair is 2, 2 and a half. We can continue on and plug in our 3, but all we need there is just 3 points. So we can go ahead and graph this now. We have 0, 0. We have 1 and 1 1/4. And we have 2. And then I need to move that little keyboard out of the way. It's not going to let me. 2 and 2 and a half. Right there. Graph your line by going through the points with your arrowheads. So at this point, you can go ahead and simplify your like terms. And we'll alter our table. And then we'll graph student practice 2. Okay, by now you should have had an opportunity to simplify your equation, fill in your chart, and graph the equation. So we have 7x plus 3 equals negative 2y plus 3. We're going to go ahead and subtract 3 from both sides, and we have that 7x equals negative 2y. From here, that is probably the easiest form of the equation that we're going to plug in. So we have 7 times 0 equals negative 2y. So 0 equals negative 2y. Divide both sides by negative 2. And we see that y equals 0. So we have ordered pair 0, 0. Next, we'll be plugging in 1. So we have 7 times 1 equals negative 2y. So we have 7 equals negative 2y. Divide both sides by negative 2. So y is going to equal negative 3.5. So we have 1 negative 3.5. Now we're plugging in 2. So we have 7 times 2 equals negative 2y, which makes 14 equals negative 2y. Divide by negative 2, and y is going to equal negative 7. So 2 comma negative 7. We can do the fourth ordered pair if we want to. We only need to do 3 to confirm, so we can now graph our points. We have point 0, 0. We have ordered pair 1 and negative 3.5. And then we have ordered pair 2, negative 7. We want to confirm that our points make the straight line. Go ahead and add our arrowheads on once we are done. Okay, and this brings us to our second topic, which is graphing a straight line by plotting its intercepts. Now, as we look at a graph, we can see that the graph is going to sometimes cross the x and y axis. When it crosses the x and y axis, those are called the x-intercept and the y-intercept. It is sometimes easier for us to pick the two intercepts and graph the equation using those intercepts rather than plotting 3 points the way that we have just done. So the x-intercept of a line is the point where the line crosses the x-axis. It has an ordered pair that's in the form of a, comma, 0, because the height on the y-axis is 0 at that point. The y-intercept of a line is the point where the line is going to cross the y-axis, and it has the form of ordered pair 0, b. Now, when we want to use the intercept method of graphing, the first thing that we want to do is find the x-intercept by allowing y to equal 0 and then solving for x. Then we would want to find the y-intercept by letting x equal 0 and solving for y. Then we would just want to find one additional ordered pair so that we have 3 points in which to plot our line. Those are the official steps. So let's take a look at example 3 here. We are going to state the x and y intercepts, and then we're going to use the intercept method in order to graph this equation. So the first thing that we want to do here is start by finding the x-intercept. And our equation is 5y minus 3x equals 15. When you are solving for your x-intercept, you always want to let your y value be 0, because when you're crossing your x-axis, the y value will be 0 no matter what. So we always plug 0 in for y and solve for x. So 5 times 0 is 0, and we're left with negative 3x equals 15. We'll divide both sides by negative 3, and x equals negative 5. That means that my x-intercept, the ordered pair where it's going to cross the x-axis, is negative 5, 0. So I'm going to go ahead and put my point on negative 5, 0 to represent that x-intercept. Next, we're going to work on finding the y-intercept. So I'm going to repeat the writing of my equation. Now, when I cross my y-axis, we should see that the x value will always be 0. So since the x value will always be 0, we're going to plug 0 in for x and solve for y. So just remember, when you're solving for your x-intercept, you're solving for x. When you want your y-intercept, you want y. So we're going to do 5y equals 15, divide both sides by 5, and y equals 3. Finding the ordered pair, remember you plugged 0 in for x, your y value is 3, and you're going to put a point on 0, 3. You now know your x and y intercepts, and your line is going to go right through those 2 points. Why don't you go ahead and try student practice 3. Go ahead and find your x and your y intercepts and get those graphed up there on that chart. As soon as you're ready to proceed, please press play and we'll check your work together. Okay, at this point you should have had an opportunity to find the x and y intercepts and graph our equation. To find the x-intercept of an equation, you always want to let your y value equal 0. So we're going to plug 0 in for y and solve for x. So that leaves us with negative x equals 6. I'll divide both sides by negative 1 to make my x positive. So x equals negative 6. That means that my x-intercept is at negative 6, so the ordered pair is negative 6, 0. To find my y-intercept, I have to allow my x value to be 0. So I'm going to plug 0 in for x and solve for y. Divide both sides by 2, and y equals 3. That means that the ordered pair that represents my y-intercept is 0, 3. At this point, you should now be ready to graph using your intercepts. So you're going to put a point at negative 6, 0 and a point at 0, 3, and draw your line through your intercepts. The last topic for section 7.2 is graphing horizontal and vertical lines. You will notice that the x-axis is a horizontal line. Specifically, it is the line y equals 0. Since for any value of x, the value of y is 0. Go ahead and look at a few points. If you have ordered pair 1, 0, and 3, 0, and negative 2, 0, all of those points lie on the x-axis. Any horizontal line is going to be parallel to the x-axis. Lines such as y equals 5 and y equal negative 2 are all horizontal lines because they're going to cut through the y-axis. What does y equal 5 mean? It means that for any value of x, y is 5. What does y equals negative 2 mean? It means that for any value of x, y is going to equal negative 2. So as you're moving along the axis, negative 3, it's going to have the y value of negative 2. Negative 2 will have the y value of negative 2. Negative 1 will have the y value of negative 2. That horizontal line is cutting through negative 2 on the y-axis. That's what's happening there. Now, how can we recognize the equation of a line that's horizontal and one that's parallel to the x-axis? If the graph of that equation is a straight line that's parallel to the x-axis, meaning it's a horizontal line, the equation will always be in the form of y equals a number. And that number will be some number in our real number system. Now we have two examples that we're going to graph here. The first one I will do, the second one I want you to practice. So we're going to graph y equals negative 3 together. So the way that I approach these, rather than memorizing that y equals is a horizontal line, I say to myself, okay, y equals means it's going to cut through the y-axis. So if it's cutting through the y-axis at negative 3, I'm going to draw a little line through there. What kind of line is that? Oh, okay. It's a horizontal line. That helped me to learn what type of line a y equals line was. It's cutting through the y axis at -3. The y equals tells you which axis that you're going to cut through. So why don't you go ahead and graph student practice number 4. Pause the recording whenever you're ready. We'll go through the answer together. Okay, by now you should have graphed student practice 4. It is y equals 2. Now remember, the y equals tells us which axis it's cutting through. It is telling us that it's going to cut through the y axis at 2. So start by putting your line going through the 2 on the y-axis. So we should have a horizontal line going through +2 on the y-axis. Now, that's how we approach the horizontal lines. We're also going to have vertical lines. Vertical lines are lines that are in the form of x equals some number. When we have vertical lines, that means that all of the x coordinates are the same, and the y coordinates are going to be the ones that are changing. It's the height along that y-axis that's changing, but the location on the x-axis is remaining the same. So how can we recognize if a line is vertical and if it's parallel to the y-axis? Well, if the graph of the equation is a straight line that's parallel to the y-axis, it's going to be in the form of x equals some number that's in our real number system. So I have 2 examples that we can work on, okay? Now the first one is not automatically in x equals form. We have to solve it for x first. So the first thing we're going to do here is subtract 1 from both sides. So we have 2x equals 10. We're going to divide both sides by 2, and now we have x equals 5. We're ready to graph that. So again, if you're confused about how to graph this, look at what the equation is telling us. It's telling us which axis to graph it on. It's saying it's cutting through the x-axis on 5. So I'm going to go to the x-axis, put my line there, and it's a vertical, oh, that was a horrible vertical line. My pen lost its way, sorry. Vertical line going through 5. So why don't you go ahead and do student practice 5. As soon as you're ready, please press play and we will check our answers together. Okay, by now you should have had an opportunity to complete student practice number 5. The first thing that you would want to do is simplify your problem down to just the x equals form. So we want to subtract 1 from both sides, so we should have 3x equals -9. Divide both sides by 3, and we should have that x equals -3. So we just have one variable to work with. We have x equals. So that's going to tell us that it's a vertical line cutting through the x-axis at -3. So if you have any questions at all about any of the topics that we have covered in this section, please feel free to contact me. I'll be more than happy to set up tutoring with you and work with you on these topics. Thank you and have a great day.